Bearing setting is a very important factor in bearing life. One of the unique characteristics of the tapered roller bearing is its capability of being set with a precise internal clearance, termed end play, or with a predetermined load, termed preload. This flexibility leads to optimum bearing life in an application if the bearing is properly adjusted. An end play setting provides internal clearance between the cup and cone assembly when the rollers are fully seated. When the clearance is too great, the rollers have excessive movement during operation. This causes cage pocket wear. Eventually, you may see a wear pattern in the cup race called scalloping. It develops when the excessive internal clearance causes the rollers to slide and skew as they travel around the bearing. The sliding action eventually leaves a scalloped wear pattern along a small area of the cup race. Preload is a bearing setting with a predetermined load between the bearing cup and cone assembly when the rollers are fully seated. If internal load is excessive, the lubricant cannot protect the bearing. This causes rapid and extensive premature spalling of the rollers and races. Electric current can damage tapered roller bearings too. When an electric arc passes between the metal components of the bearing, it may leave a pit. Under close examination, it looks like puddled or melted steel. If the arc passes through the bearing during operation, the damage may appear along the entire line contact area between the rollers and cup. This is called fluting. Under magnification, the flutes appear as a series of inline pits caused by electric arc burning. Let's quickly review the three types of surface pitting we have discussed so far. A spall has rough and grainy texture. Corrosion pits have a rusted appearance, and electric arc pits have a smooth texture. These characteristics may assist you in pinpointing your problem. Our last damage mode is Brunelling, of which there are two types. True Brunelling appears as a roller-spaced indentation on the race as the direct result of high impact or shock loads. Close examination will reveal the characteristic that distinguishes true Brunel damage from other roller space damage modes. When magnified, hone marks remain visible across the true Brunel damage. This highlights the fact that there is no friction wear in true Brunelling, only the impact damage on the race. False Brunelling also has roller-spaced wear patterns on the races, but the grinding and hone marks are not visible across the indentations. False Brunelling is caused by vibration of the rollers in an axial direction against the cup and cone races, usually while the bearing is not rotating. This often occurs while the equipment containing the tapered roller bearing is being transported, or when the vibration of adjacent machinery affects a bearing system. Now you can better understand how a tapered roller bearing functions. You have seen the most common damage modes, and we have explored some of the reasons for the premature wear in the bearing. Troubleshooting is a challenging process, yet a careful collection of symptoms and facts regarding the bearing and its specific application can lead to a full damage diagnosis. Sometimes further analysis may be necessary. This is best accomplished by linking the skill of your maintenance team with the talented resources of the Timken Company. In the end, we want you to get the best value from your Timken tapered roller bearings.